LeetCode Problem 235, Lowest Common Ancestor of a Binary Search Tree. Hey everyone, this is KeyStrokes. I'm a senior software engineer at one of the FAANGs, and I like to make videos on LeetCode problems, latest AI ML trends, interview tips, and coding, and basically anything and everything related to computer science and coding. Today we'll take a look at LeetCode's problem 235, which is a medium problem, and we need to find the lowest common ancestor of a binary search tree. So let's take a look at the problem statement. We'll be given the root of a binary search tree, and we'll be given two nodes in the same binary search tree. And our goal will be to find the lowest common ancestor of the two given nodes in that binary search tree. Looking at the examples, in the first example, this is the tree given to us, and then the first node is 2 and the second node is 8, which is 2 and 8. And in this case, the lowest common ancestor basically means keep traversing all the way up to the node until we find a common node, which is 6 in this case. So the output becomes 6. Similarly, in the second example, we see that the value of P is 2, that's our first node, and Q is 4, which we can see right here. And this is an interesting case because 2 is a parent of 4. So 2 basically becomes the lowest common ancestor of 2 and 4. So let's see everything that you need to know to solve this problem. You need to know some basic programming concepts. In this case, that's recursion. And then you just need a basic understanding of binary search tree. So let's jump into brainstorming and see how we can solve this problem. Okay, so let's say this was the binary search tree that was given to us. So in this case, 6 becomes our root node. So this becomes our root. Then we have 4 and 9 as the two nodes for which we need to find the lowest common ancestors. So this becomes, let's say, P, and this becomes Q. Now for this case, just by looking at it, you can tell that 6 is the lowest common ancestor for the nodes 4 and 9. Because let's say if you go from node 4 all the way up to the root, then this is the path you'll take. Similarly, if you go from node 9 all the way up to the root, this is the path that you'll take. And the common node that you find, which is the lowest common ancestor, is 6. And in this case, that's pretty simple. And in this case, let's say if we were iterating, we'll start with the root node. Here we'll check that 6 is greater than 4 and that 6 is less than 9. And the moment these two conditions satisfy, then we immediately know that this is the lowest common ancestor. So in this case, 6 becomes our final answer. Okay, so let's try another example and make it just a bit more tricky. Now in this case, 6 is the root and node 0 is P and node 3 is Q. Now in this case, we notice that 6 is greater than 0 and 6 is greater than 3. And just by looking at the tree, we can tell that the lowest common ancestor should be 2. So somehow we need to arrive at 2. Now because 6 is greater than 0 and 6 is greater than 3, we can conclude that the lowest common ancestor will be on the left subtree, which is basically this left subtree. And that's because both of the values of P and Q, that is 0 and 3, they are smaller than the current node that we are working on, which is 6. So once we realize that the answer will be in the left subtree, we can update our current root to be the left child of the current root. So basically, this root becomes right here. And now we just operate on this left subtree with the assumption that 2 is the root that we are working with, and then P and Q, they remain the same. Now with this new root, let's see how things look like. So 2 is greater than 0, but 2 is less than 3. And because of this condition, we can say that 2 is the lowest common ancestor of P and Q, that is 0 and 3. So 2 becomes our answer. And we can stop our iteration here. Okay, so let's try another example. And in this case, we go for a deepen. So this time P is 3 and Q is 5. And by looking at the tree, we know that 4 is the lowest common ancestor. So we start with root as 6, and we see that 6 is greater than 3 and 6 is greater than 5. So this basically indicates that the lowest common ancestor will be in the left subtree somewhere. So basically this left subtree. So let's move on to the next iteration then, where we move our root to the current root's left child, which is 2 in this case. So this becomes our new root. And now this basically pushed us in the left subtree. So now with the new root, we notice that 2 is smaller than 3 and 2 is smaller than 5 as well. So now because the current root is smaller than both P and Q, this basically indicates that the lowest common ancestor is on the right subtree, which is this part. So let's move to the right subtree, that is update our root to be the right child of the current root, which is right here. Now let's see how things look like with this new root. So our new root is 4. So 4 is greater than 3 and 4 is less than 5. And so because of this opposite matching, we can confidently say that 4 is the lowest common ancestor, and so this becomes our answer. Okay, so let's take a look at one last example where again 6 is the root, 2 is p, and 4 is q. And if you look at it, you can tell that the lowest common ancestor in this case is 2. And that's because if you follow 4 all the way up to the root, this is the path you take. And similarly for 2, if you follow the path all the way up to the root, you can see that the only overlapping nodes are 6 and 2. And so 2 becomes the lowest common ancestor. So let's see how do we tackle this. So we start with root. We notice that 6 is greater than 2 and 6 is greater than 4. So this basically means that the lowest common ancestor is somewhere in the left subtree, which is this. So we update our root and make 2 as our new root. Now here if we do the same check, 2 is basically equal to 2 and 2 is less than 4. Now just because the root is equal to the current p value, this indicates that 2 is our lowest common ancestor, and so 2 becomes our answer. Now if this was the other way, let's say 3 was the value of p and 4 was q, then in this case basically the condition will become 2 is less than 4, 2 is less than 3, and because 2 is smaller than both 4 and 3, that means our lowest common ancestor would be in the right subtree, and so we update our root to now be at 4. And now if we do the same condition check, we can see that 4 is equal to 4 and 4 is greater than 3. And because 4 is equal to 4, this means 4 is the lowest common ancestor of 3 and 4, and so 4 becomes our final answer. So in summary, if the current root either becomes equal to p or q, then that becomes our lowest common ancestor. And that's because either of p or q, it's in the path all the way up to the root of p and q. So in summary, we have 3 cases. If root's value is greater than p and root's value is greater than q, then our lowest common ancestor is somewhere in the left subtree. Otherwise, if root's value is less than p and root's value is less than q, then the lowest common ancestor is somewhere on the right subtree. So this is first, this is second. And the third case is if the value of root is equal to p or root value equal to q, then root is our answer. And then if none of these match, basically root is again the answer, and then the condition becomes root is greater than p, root is smaller than q, and that becomes our fourth case, which basically becomes our default case, assuming that p is smaller than q in the given input. Okay, so here's the pseudocode of the solution that we just discussed. We are given the root of the binary search tree and 2 random nodes in the binary search tree called p and q. Then the first condition we check is if the root.value is equal to either p.val or q.val, that is, the root's value is equal to either of the 2 random nodes that are given to us. If that's the case, then the lowest common ancestor is the root itself, and we just return this value and we are done. Otherwise, if root's value is greater than both the given nodes to us, that is, it's greater than the value of p and q, then it basically means that the lowest common ancestor is somewhere in the left subtree. So in this case, we just recursively call the same method again, but in this case we pass the left subtree. Otherwise, if the value of the root is smaller than both p and q value, then that basically means that the lowest common ancestor is on the right subtree, and so in this case we recursively call the same method again, but this time with the right subtree. And if none of these conditions match, then basically root is the lowest common ancestor, which we can return by default. Okay, so I think we are ready to code, but before we jump into our IDE, if you've been liking this video so far, please don't forget to like this video and to subscribe to my channel, and you can show me your support by buying me some coffee or by signing up to my Patreon. And you can also reach out to me for one-on-ones where I can guide you through some basics of programming, help you with interview preparation, help you with any computer science topics, be a consultant on your project ideas and how to execute them, and feel free to fill this form out if you have something else to talk to me about. So that's it. Now let's jump into our IDE and code the solution out. Okay, so here I have LeetCode, and this is the solution class that we have to work with. I'm going to copy the method signature and I'll jump into IntelliJ and paste it in the solution class that I have. Now this method takes in a root and 2 nodes p and q. So here the first thing we'll check is if the root's value is equal to either p or q. So for that we can write if root.val is equal to p.val or root.val equal to q.val, then basically root is our solution. So in this case we can do return root. Otherwise, if root.val is greater than p.val and root.val is also greater than q.val, then this basically means that the lowest common ancestor is on the left subtree. And in that case, we can just recursively call this method again, but with a different root. So we can do return lowest common ancestor, and this time root.left, and then pass the same for p and q. Now similarly, if root.val is smaller than p.val and root.val is smaller than q.val, then this basically means that the lowest common ancestor is on the right subtree, and we can recursively call this with the right subtree and with the same p and q. And then in the end, as a default case, we can just return the root, and that should complete our program. Now I have a main class here with some of the examples from LeetCode. So I'm going to run this program and see if our program passes the test cases. And yes, we can see we get correct answers for all the 3 test cases we had. So let's copy our solution and go over to LeetCode and paste it in there. So jumping here and pasting it in, let's run it for the base cases first. And yes, they were accepted. And now let's submit it for the actual test cases and see how well it performs. And we can see that our solution was accepted and it beats around 93% of the solutions. Okay, well, that was pretty simple. I hope this video now helped you on how to find the lowest common ancestor in a binary search tree. And if it did, then please don't forget to like this video and to subscribe to my channel. And you can follow me on Twitter, and please show me your support by buying me some coffee or by signing up to Patreon. And please feel free to reach out to me for one-on-ones if you're interested in that. I'm working on the next video and it should be coming out soon. And in the meantime, please check out the video on the screen. You might have fun solving this problem. Good luck, and I'll see you next time.